This is The Necessity of Terraforming Mars by Oliver Pourghasemi, Grade 5, Greeley Middle School, Earth, Milky Way Galaxy. In 600 years, could our Earth be gone? Yes. Within the next several hundred years, Earth has a high likelihood of experiencing an extinction level event. Well, first off, what is an extinction level event? An extinction level event is when a large event happens that is strong enough to make a species extinct, like the asteroid that wiped out the dinosaurs. Other extinction level events are heavy meteor showers, severe droughts, and catastrophic pandemics. A pandemic is a deadly, widespread disease. Did you know the United Nations Office for Disaster Risk Reduction estimated in 2023 that there is a 14 to 98, median 56% chance of an extinction level event by the year 2700? Median means middle. But there is a way to save us. Far, far away, there's a planet that could save humanity. So I don't want you to think, oh, terraforming Mars, blah, 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 boring. So I promise to make it interesting. So let's get started. Terraforming Mars with lasers. Lasers. Lasers! Today our most powerful laser is the Eli MP. It can produce 10 petawatts of power for 1 trillionth of a second. We need to double its power and keep it ongoing in order to successfully terraform Mars. Then we melt Mars. Yes, doing this makes Mars ever more terrifying, filling the skies with enormous, horrifying storms and streams of molten rock on the ground. On the good side, melting it would release more oxygen, and in the quick time it cools, it would also release steam that would make clouds that would rain down and create oceans on its surface. Molten rock is lava. Next, we import nitrogen from Titan. To do this, we need to make big factories on Titan's surface and shoot it to Mars in small capsules. Once they land, they will explode, well-ish, and release nitrogen to Mars' new and improved atmosphere. Ooh, found some. Done. But on the surface, it would still be very hard to breathe and flammable. When we add a biosphere, Mars will become much more livable. We'll just use our many powerful lasers to grind the rock into soil. Then we'll introduce volcanically thriving plants. When we populate the oceans, adding phytoplankton, then we gradually introduce zooplankton that will evolve into fish, aquatic plants, and even whales. And that will solve, that fire thing we had earlier. Cool graph. I'll give you a minute to look at this. Creating a magnetic field for Mars. The magnetic field for Mars doesn't need to be as big as Earth's, but it needs to work. By work, I mean it will protect Mars from solar winds and other space dangers. We could do that by making a magnetic umbrella in front of Mars. A good old superconducting ring would do the job. Or we could heavily nuke Mars. Like this. How would it help? Nuking Mars would release H2O, nitrogen, and carbon from the ground, but it would also cause serious radiation. So that's a no. Okay, so that's that. Hey, I want to be in on the fun. Boom. Take that, Venus. Here are some random Mars facts. Mars has 2 moons. Mars is named after the Roman god of war. Mars has an orbital period of 1.8 Earth years. The diameter of Mars is 4,220 miles. I want to see how many of you recognize the slide is reused. And citations. Take a look. And who doesn't love a good old photo gallery? It's never gonna end. Thank you. This was an Oliver Pourghasemi production. It's really nice to make a STEM video for you all again. See you next time. Credits: Director, Oliver Pourghasemi. Producer, Oliver Pourghasemi. Editor, Oliver Pourghasemi. Makeup and costume, Oliver Pourghasemi. Basically everything, Oliver Pourghasemi.